So, I accidentally stopped mid-lesson when we were on task statement 2, so you're going to get this one in 2 parts because I'm not redoing the beginning. All right, so let's solve all the triangles. Okay, I have a nice triangle here, and when I say solve the triangles, that means find all sides and angles. Okay, that's the definition of solve a triangle. Find all the sides and the angles. Okay, the angles can be easier because I know 90 and 20, so this one's going to be 70 because the inside of a triangle always adds to 180 degrees. Now finding the angles, not quite as easy. So let's go through it. Sorry. Finding the side lengths, not so easy. So let's go through it. What is the length of segment AB? So this, if I'm looking at my 20-degree angle, this one is adjacent to 20 degrees. And we've learned that the ratio, so for 20 degrees, the ratio of adjacent over hypotenuse is, oh no, where is it? I think it's over here. I'm in the way. Yep. So the ratio of, what did I say, adjacent to hypotenuse for 20 degrees is 0.940. So let's go look at that. 0.940 equals 0.940. And we know our hypotenuse value. So I can actually replace adjacent over 8.5 equals 0.940. I have done a very poor job laying out my work. So I'm just going to rewrite all of that because that will be very annoying. All right, so for 20 degrees, we can say adjacent over hypotenuse equals adjacent over 8.5 equals the value. I'm just going to get it out here. You can have yours open in your Google Doc that I shared with you. I've got the same thing here. Okay. So for 20 degrees, adjacent over hypotenuse is 0.940. Now we're solving for adjacent. What I usually do at this point is put it over 1 and cross multiply. So adjacent times 1 equals 8.5 times 0.940. 8.5 times 0.94 is 7.99 equals adjacent. All right, so we used the given ratios in the book. I saw that review just a little bit. I looked up 20 degrees on my table and I saw that adjacent over hypotenuse was 0.940. Okay, I could actually say A, which is much easier. A over 8.5 equals 0.940 over 1. And then I just cross multiplied. So A equals 8.5 times 0.940, which is 7.99. Now, that's all well and good. We found AB. That was great. In a right triangle, well, pause for a second. If it says solve, I want to find AC also, and that is my opposite one. Now let's actually, hold on a second. That's opposite of 20. I'm going to change colors here and erase a few things. Let's say I want to solve for AC using 70. Well, that's the adjacent side to 70. All right, so if I go to my handy dandy chart right here and I look up 70 degrees adjacent, I see adjacent over hypotenuse is, for 70 degrees, adjacent over hypotenuse is A over 8.5. Look at my ratio. It is 0.342 over 1 because I can put a 1 underneath anything. I cross multiply. I get A equals 8.5 times 0.342. 0.342 times 8.5. 2.907. So that's what the value of this one is. 2.907. Okay? We can argue over how many decimal places you need, and that's fine. Now, I'm actually going to double check my work. I'm taking this lesson just a step further for those of you who are interested. I can use Pythagorean theorem to check. Pythagorean. Remember a squared plus b squared equals c squared. I can say 2.907 squared plus 7.99 equals 8.5 squared. And I really can't put that equals there yet. I need to put a question mark over the equals to check. All right, so picking up my handy dandy calculator, 2.907 squared plus 7.99 squared, and then I'm going to do 8.5 squared. So here you see this one. That's the sum. It's a squared plus b squared. I have 72.29. And then I checked it against 8.5 squared, which is 72.25. They're equal. Okay, that's close enough. So we just checked our work to make sure we got it right. So I can actually erase that question mark and put a check mark. Okay, we did it right. Gold star. Yay. All right, I'm sorry, that was a little tangent. Let's move on to number 2. In a right triangle with one angle measuring, let me see if I can add more space here. I don't understand how that add more space thing works. I really wanted to. I think maybe it does it at the end. Oh well. In a right triangle with one angle measuring 40 degrees, and the leg opposite the 40 degree is 5 centimeters. What is the length of the hypotenuse? Okay, so I'm going to draw number 2. Let's go ahead and we can draw a willy-nilly right triangle. Oops, that's a really bad willy-nilly right triangle. That's okay. 40 degrees. Let's do this one as 40 degrees. That is 90. The leg opposite the 40 degree is 5 centimeters. What is the length of a hypotenuse? Okay, so I know opposite and I know hypotenuse, or I need to know hypotenuse, and for the 40 degree angle. If I look at my chart, I'm looking at 40 degrees, opposite and hypotenuse. My ratio is, first let's do this, opposite, hypotenuse. If I look at my chart, my ratio is 0.643. I'm going to put that over 1 because I can, because now I need to cross multiply. So that gives me 5 equals 0.643 times my hypotenuse. Now I can divide both sides by 0.643, and that gives me my hypotenuse is 5 divided by 0.643. My hypotenuse is 7.78. Okay, now in my land, solving means finding all the pieces and parts. So hypotenuse is 7.78. I'm going to use Pythagorean theorem. 5 squared plus b squared equals 7.78 squared. 7.78 squared is 60.528. I'm keeping it in my calculator. Oops, that's not right. I squared 25, so I should not write 25 squared. Plus b squared. So subtract 25 from both sides. I get b squared equals 35.5. Square to both sides. B equals 5.96. So we got this side. I need to finish it. I want you guys to understand that solving means doing all of them. All right, number 3. What is the length of segment DE? We're going to call this A. Well, let's call it B. C is always the hypotenuse. All right, so if we had 50, we know 50 degrees. Let's change colors so we don't get it confused with other things. For 50 degrees, we have adjacent. And we want DE, which is opposite. So actually I want opposite over adjacent. So for 50, we've got opposite over adjacent. And if I look at my table, this table right here, for 50 degrees, opposite over adjacent is 5 over A is 1.192. I'm going to cross multiply. I get 5 equals 1.192 times A. Divide both sides by 1.192. 1.192. I get A equals 5 divided by 1.192. 4.195. 4.195. Opposite over adjacent. Where'd I get that 5 from? Oh. Opposite over adjacent. So it's B over 6. I'm sorry. You guys are probably sitting there again going, dude, what is she doing? What in the world? I have no idea. Somewhere I got a 5 in my head. I don't know where I got it from. So we've got B over 6. Opposite over adjacent is 1.192 over 1. Cross multiply. B equals 6 times 1.192. Okay, it just goes to show you, never get to your answer and just circle it and move on. Always go back and look to see what you were doing. 7.152. And we could use Pythagorean theorem to find C if we wanted to. All right, number 4, I'm going to keep in red. In a right triangle with one angle measuring 70 degrees, sorry. Not bad. 70 degrees. The leg opposite the 70 degree angle is 12 centimeters. What is the leg adjacent to the 70 degree angle? Okay, so I've got opposite over adjacent. So I want to use 70 degrees, opposite over adjacent. Okay, opposite over adjacent. So I'm doing 12 over A. And my chart says opposite over adjacent is 2.747 over 1. Cross multiply, I get 12 equals 2.747 times A. Divide both sides. I have A equals 4.368. 4.368. Okay, should it be a smaller length? Yes. That should be my short leg. And we could find hypotenuse by doing Pythagorean theorem, which is cool. All right, that took a long time. I may have taken it a little further, and then messing up stinks, so I'll stop it here. Good job.